I'm Ryan, and I'm going to be doing a presentation on aircraft catapults. Introduction. So what are aircraft catapults? The runway on an aircraft carrier, and why are they important? The runway on an aircraft carrier is too short for a normal plane to take off, so you need an assisted launch system to accelerate the plane at a very high velocity for it to gain the necessary lift. And the catapult is a mechanical system that attaches to the plane and shoots it forward, again, to gain this necessary lift. Here's just a video of kind of what it looks like. So as you could see in that past video, the plane accelerates very abruptly and quickly, and that makes taking off actually somewhat complicated, not in terms of the pilot himself, but in terms of the equipment. Modern aircraft catapult systems accelerate the aircraft, which can weigh up to 45,000 pounds. Well, they normally weigh around 45,000 pounds. From 0 to 165 miles an hour in only 2 seconds. Over this time period, the pilot experiences around 4 G's worth of force. In this picture, I'll get into this later a little bit more, but a jet blast shield needs to be raised because the plane, when it takes off, they put the engines on full power, and this blast of air will blow people off the ship or equipment like other planes, and so you need to have a shield to deflect the air up into the sky. Some background in history. So the initial goal of the aircraft carrier was to launch planes off of battleships and cruisers. This was first thought of around the 1910s, like early 20th century. Initial ideas were gunpowder, the flywheel technique, and compressed air. And in 1928, the gunpowder design was decommissioned due to lack of use and also explosives. Okay, so on November 14th, 1910, the first plane was launched off of a ship. However, this was without a catapult system. But the planes were a lot lighter back then and easier to launch off of ships. They needed less of a runway. And on July 31st, 1912, the first test of a catapult was done using compressed air. It was unsuccessful, however. On November 12th, 1912, a modified compressed air catapult was tested with success. On November 5th, 1915, the first successful launch of an aircraft from a ship underway was using a catapult system occurred. And on December 14th, a plane was successfully launched using a gunpowder catapult. In 1934, the Navy announced plans for a flush deck hydraulic system. This system would then go through into World War II. In 1940, a catapult procurement program was established for the entire Essex class of carriers, which went through World War II and into the early Cold War, but then they started to get decommissioned. Hydraulic catapults had limited effectiveness and little use, which was part of their issue. And the old system was replaced with a more advanced hydraulic system, I think called the H-12 system, which could launch an 11,000 pound plane at up to 70 miles an hour. This was, however, much slower than the current catapults can do, which is no surprise considering it was the 40s. In 1950, the Royal Navy implemented an experimental technology which was a steam-powered catapult, and they actually let the U.S. borrow their ship, the HMS Perseus, in 1952. The U.S. then adopted the British design of the steam catapult and implemented it on their own ships in 1954, where the USS Hannock was recommissioned as the first carrier with a steam system. This system is still in place today. So the current design and application. So how they work. So first, the steam is transferred into an accumulator tank at a very high pressure, reaching up to 465 psi. After the desired pressure is reached, a flow control valve stops the inflow. Then the jet blast deflector is raised, as I mentioned earlier, using a fairly simple hydraulic system. The tow bar on the aircraft's nose gear, as seen in this picture here, is then connected to the shuttle, which runs along a track underneath the flight deck to attach the airplane to the catapult system. And a holdback bar is attached to a mechanical grab. A nose bar is attached to the back of the plane to keep it in place, because before the airplane takes off, the plane puts its engines at full power. The shuttle is attached to two pistons, which are held in cylinders with slits below the deck. The slits are covered by I think a rubber filament to avoid steam escaping. And then above the cylinders is a track with wheels, as seen right here. And track with wheels is seen right there, which is connected to the shuttle. So the shuttle runs along a track connected to these pistons. A hydraulic tensioner then pushes the system forward, the shuttle and the pistons, slightly to release any slack within the system. The pilot then puts their engines onto full power, and the holdback bar holds the plane in place. The launch valve is then opened, and steam rushes into the cylinders with the pistons. The pistons are pushed forward at an extremely high force, in this system, exerting 750 kilonewtons worth of force, and the plane accelerates from 0 to 165 miles an hour in just 2 seconds. The pilot, I think I said earlier, experiences 4 G's worth of force. The pistons then hit a water brake. This activates a sensor, which activates the retrieval system. The plane takes off and breaks free from the shuttle. And so the piston hits the water brake, and it activates a sensor. The sensor opens the exhaust valve, and steam is released into the atmosphere via the flight deck, actually, so you can physically see the steam escaping. And the retrieval system is activated. The mechanical grab, which is right there, which is the same as actually the tensioner is connected to the mechanical grab, moves along a track of its own, along the same track as the shuttle, via a pulley system, and it grabs onto the shuttle and the piston and pulls everything back to its starting position to reset the system. And I said that. Maximum pressure is 465 psi. The different pressures are used for different sizes of planes, so it's very important to know the weight and type of plane and how much force is needed to lift them off the ground. And this is a factor that comes into effect when in the system. So the future, EMALS. What are they? Electromagnetic Aircraft Launch System is what EMALS stands for. So this is not a new idea. You can actually see this concept in a lot of modern roller coasters that accelerate at high speeds. Basically, there's an electromagnet, and it would push the shuttle piece forward with another electromagnet activated in front of it that pulls it forward. And then this system repeats at an extremely high speed and can launch the shuttle forward. Theoretically, if you could somehow figure out how to do it fast enough, you could make the shuttles move at the speed of electricity, but this is obviously not possible in anywhere near the near future. In any near future, because of, friction, so you couldn't actually get it to be the speed of electricity. But also just the timing would be near to impossible with today's technology. Well, it would be impossible with today's technology. Why is it better? So you get a higher launch energy, which means you can launch heavier planes, and you can. The reason that planes actually launch into the wind on an aircraft carrier is they need the extra lift. This would mean that you don't necessarily have to have as strong of a wind as is currently necessary to launch planes. There'd be more accurate speed control. It would control the speed within 3 miles an hour of the desired takeoff speed. So this is important because, as I mentioned earlier, different planes require different speeds to take off. There'd be a smoother launch, which is easier on both the gear, the catapult system, and and the plane itself. Which also leads to it being easier to maintain. It's a simpler system. It would, in theory, it'd be more reliable, and it would have a safety mechanism to prevent bad takeoffs, and it'd be more efficient, 10 times better than the steam system. There would also be improvements in terms of weight and volume of the system, which is better for the aircraft carrier as a whole, just because it's less stuff. A new type of aircraft carrier, the Ford class carrier, is actually implementing this technology today. I think the Ford, yeah. Anyway, some of the problems with the system, however, are although it's potentially more reliable, it's currently 9 times less reliable than the in terms of critical failure than the steam system. So although it's safer to take off, the odds that the system just completely doesn't work and you lose an entire catapult system is 9 times greater than the steam system. So this is an issue that needs to be fixed in the future. And also President Trump doubts its survival during combat, and it's a very huge monetary investment. Millions, maybe billions of dollars would go into continuing this technology and bringing it to the full scale. And he thinks that since we've had the steam systems for 65 years and they've been tested in combat and have proven themselves, we should just continue on with the steam systems. And so another thing is an engineer said in an interview that for this new electromagnetic system, their goal is to fit about an acre worth of equipment into the size of a shoebox, which is pretty crazy in terms of engineering marvels, but they've been able to do it. This is actually a test of the catapult system. And so, any questions? Take that as a no. Thank you for watching. Remember to like, comment, and subscribe. Smash that like button, and I'll see you next time.